So I hope everyone can see the screen with this big QR code, which goes to the book website if you're interested. But I will tell a bit more about what's in the book. But especially today, I will be talking about how design thinking and prompt cards improve AI products and services. So, and if you do have any questions, please put them in the chat. And I think Stefan will sort of aggregate them, and then we'll see if we can address these at the end of this talk. And I do have some interactive moments within this talk. So let me start. Does anyone know who this person is? I think most Dutch people will, but maybe Flemish people or people from abroad might not know this Dutch person. So if you know who it is, you can put him in his name in the chat, and I'll tell you a bit more about it. So please, if you know who this is, I'll just wait a little bit and see if people are using the chat. And it's not just a trick question. Yes, it's the Prime Minister of the Netherlands. His name is Rutte. Thank you, Philip and Adrian. Very fast, Patricia, Hans. And I'm showing you this picture. This is a picture from the archive in the AMP. And it's almost, I think it was added there about 18 months ago. But last month, our Prime Minister, something the Prime Minister did with his phone became big news in the Netherlands, quite a fuss, because he deleted all text messages from his Nokia phone. He's using a Nokia phone right here in this picture. And because everything he does with his phone is a matter of national interest, so he's not allowed to just delete or archive these messages on his own. And there were quite some questions and debates about that. But this photo is in the archive of AMP. And what I want to show you is that there is a human added metadata to this picture and AI added metadata. So as we can all already see, some of you added Mark Rutte, even with an N, Rutte, Premier van Nederland, dus Dutch Prime Minister. I want you to think about what other words might have been added to this picture. It was taken 18 months ago, while the fuss about this very topic was just 1 month ago. So 18 months ago, what would you think humans would have added in the data set with this picture? And the first one already, you already gave Rutte, but what other words would you use if you were an archivist, archiver for the AMP, saw this picture? What would you enter? Again, please put your answers in the chat, your metadata, your tags, your labels. Message, yes. Blue suit, very well. Phone, yeah. WEF, World Economic Forum, climbing wall, that's art. I think it's more of the different kinds of clay and earth materials you find in the Netherlands. But yeah, these all seem very clever, but what the actual human did was added debate, because this picture was taken during a debat. It was about verantwoording, taking responsibility for the finance plan, and you could say miljoenennota. So it's a plan about how to spend millions of government funding and government money. So this was the occasion where the event where this actual picture was taken. So these were the words that were added by a human. Now, if you were to look up just 1 month ago, Mark Rutte or Rutte and mobile or smartphone, you wouldn't have found these because, okay, although you, my fellow audience, are quite smarter than just one human that added the metadata, there's no Bluetooth or phone added by a human. But what an AI system did, and I learned this from the editor-in-chief from AMP, Freek Staps, he said that the AI added metadata was grown-up, volwassene, a male, man, businessman, zakenman, which maybe doesn't make sense if you know what Mark Rutte does, but wireless technology is accurate. Draadloze technologie is the Dutch word, and mobile telephone, so mobiele telefoon. So if you were to think about combining human metadata with Rutte and AI, machine learning added metadata because of a model that knows how to interpret images, a computer vision model, you were able to find this picture when you typed in Rutte and phone. So you have to thank both the human and the AI, and this will be a key point of this talk. So another example, which part of this photo has been manipulated, you think? Could it be the lights? Could it be that the dog wasn't on the skateboard, or maybe the lens? What do you think? The skateboard? Veronica skateboard. You're very interactive, very proactive typing your answers. I really like it. The lights. Yes, that's a good guess. Probably. Anyone else? Adrian and Veronica said skateboard, lights. Maybe you have another guess. The dots right under. Yes, the black and white color. Well, okay, let me admit this was a trick question, because this is an entirely synthetically generated picture. This dog does not exist. This skateboard does not exist. There hasn't been any specific manipulation. The entire image does not exist. It's been created by a machine called DALL-E, which is developed by OpenAI. And it was even more so interesting, generated by just typing this sentence: a skateboarding dog at night, Voigtlander Nocten 10.5 millimeters with a focus of 0.95. So all it took was a human to enter this line of text, a prompt, or just a command to generate this image. And it even knows the Voigtlander Nocten aesthetic and which kind of shutter time and lens to generate this very specific image. And I asked a photo editor at the Dutch national newspaper if this would have been a brief she would have given to maybe a real photographer, and said, yeah, it might be if this were an article for maybe our weekend edition about animal companionship and the value and power of that. But then I would call this an illustration, and obviously not a photograph, because it's not a photograph, because it's illustrated, it's synthetic. Now, this was created with DALL-E from OpenAI. And again, you might have heard about this in the news. Very interesting what a machine learning model could learn from taking all these images. This is trained by millions of images with labels. And if you prompt it with this kind of text, a skateboarding dog at night, you get these kind of images generated, and there are many more. Now, third thing, maybe you have a bookshelf which has been sorted the same way as in this picture, as you can see, by color. Now, what is interesting is there is a difference between an algorithm and a machine learning model. Now, if you were to train a computer to sort your books, when you get a new book, say, for example, my own book, and you were to use this part of the book to sort it, you would see it would be green. So your algorithm might say, find all the books, find all the colors, find the green books, put my book next to the green books. If it's dark green, put it left to it. If it's light green, maybe put it to the right, and do this for every book you see until all the colors are sorted. That would be an algorithm, a recipe. But what actually happened, this book, I think, which Stefan said just came out 2 weeks ago. And I knew it was in a physical bookstore. So I went to visit the bookstore and I asked where my book was, and they put it under science management. And so I went back to the bookseller and I said, I can't find my book. And then he said, it's over there. And I said, why is it there? And he said, oh, would you have guessed it? It would be in a different area. And I said, maybe it could be about ICT or design or philosophy or creativity, because these are things the book is about. And then we had a small discussion. Now, what was ironic is that in the book, Marlies, my co-author, she explains the difference between an algorithm and a machine learning model by using book sorting as an example. And as she said, so if you were to sort books by alphabet, obviously we look at the last letter of the author and then look up the letters in the already sorted bookshelf and then put it next or before the book that it's has the same letter. For me, it would be a V, obviously. And for color, it would work, and you don't need machine learning models because it's a very straightforward task with very clear rules. But if you were to sort it on genre, it would be entirely different because you have to have an agreement on that. It might be hard for a human to do, but a machine learning model could learn the entire contents of the book and could place my book based on similarities in contents of other books that have that do cover design, creativity, journalism, content creation, and all these kinds of things. So then an algorithm wouldn't be of use because there were too many exceptions, but a machine learning model would be able to place my book between other relevant books that it might be comfortable with. So now, when we talk about algorithms and machine learning models, you could write an algorithm to sort the cupcakes from the Chihuahua, but it would be hard because you have to set up the rules, but there are too many exceptions. For us humans, this image might be very well known. It's quite easy for us to detect the differences, but to create a set of rules, an algorithm that could distinct between Chihuahua and Muffin might be hard. Now, another example, which one of these is a bagel or a donut? And this is a bit harder for me as well, as although I know what the answer is. So I would say, when is something a bagel and when is something a donut? Can you decide which one it would be? Now, my point here is to know what we can do with machine learning, and I'll show you what card sets and toolkits and frameworks can do. We all need to love algorithms. That's what Stanford University tells us, the D school. You don't have to know the code, but you do need to know what the code can do. And if you understand what machine learning algorithms can do, you can better envision the implications of your designs. Even more so, you can influence conversations about data and bias. So, from my opinion, it's not necessary if you're a journalist or an academic or a designer, or working with information as a big part of your everyday work. It's not necessary for everyone to be able to know how to program, but to know how to read and to know what code can do. Again, it can help you conceptualize, but also have conversations about data and bias. And today I'll show you some card sets and frameworks that can help you with these conversations too. Now, just because we do have to mention these, there are three big bad Bs when it comes to AI and machine learning. Obviously, there's bias, there's big tech, and there's a black box. These are the things most people tell you when you ask them if they're afraid of AI or what they don't like about AI applications. Then they come up with these three things mainly. Now, this is something that the German editor, the German newsroom Bayerischer Rundfunk did. They tried to see if a hiring algorithm that was used by Lufthansa, BMW, and ADAC, if it was biased. And so they did their research, investigative journalism, and hired all these kinds of actors with literally and figuratively different backgrounds, but using the same script. They recorded videos to apply for the same job and then see what happened if they were invited for an interview or not, because the AI model would determine if you got invited or not. And in this article, they explain how they did it and what the outcome was, and we'll share all the examples and links with you after the talk. It's very interesting. So these journalists know and try to adversarial audit this algorithm. So they need to know what algorithms can do, how they work, in order to be able to investigate. So you need algorithmic literacy. Now, a lot of you, I know, have seen this documentary on Netflix, The Social Dilemma, about the technology that connects us, also controls us. And well, there's a new law in the European Union, the Digital Services Act, that has been signed into law, and it helps us to have more privacy and defend ourselves against online harassments and other nasty internet phenomena. But again, we must be critical and skeptical about the power of big tech, the systems they control, and the computing power they have at their disposal, and be able to research that as well, to question that and to make use of that. Now, thirdly, talking about big tech, this is the black box opened up by Google Vertex. This is their explainable AI application. If you were to train a model that knows how to distinguish between cats and dogs, and you train the model on images like this, then for each prediction, it tells you what pixels gave the most positive results for your prediction, for your score. So it tells you the combinations of input on which the model determines if it's a cat or a dog. And as you would wonder, as a human, we might think of the pointy ears for detecting the cat, but this model uses different areas of the image to determine if it's a cat or if it's a dog, as you can see. So this is a model explaining itself to a human. What were the specifics for determining or predicting a certain classification for an image? So again, this is in a way promising that the black box is opening up. And this is something you can use if you use Vertex Explainable AI. This is already at your disposal. Now, just some examples to get us started. Why should everyone you know learn more about AI? I have 7 reasons. But for now, I would like to ask you if you can put your reasons in the chat again. So why should everyone you know learn more about AI? I will state 7 and see if we have the same. You probably will have more to add. I'll just wait a few seconds. Give me some reasons in the chat. Why should everyone you know learn more about AI? Improve and understand health and environment, to see it, spot opportunities, to bring more transparency in the black box, will be more and more introduced into our daily lives. Yes, to learn about the limitations of the advice that maybe machine learning models can give you, to not simply undergo this new development, but face it in an informed, expert manner. Predominantly present in our everyday, to better understand our own minds and bias. Yes, that's a smart one. Learn what it will do in our life. Well, I think these are all great answers, and I think they reflect, to avoid discrimination, they reflect what I've come up with. So let me just go there. This demystification, obviously, we should take away the magic and the fears from the perceptions that people have by just showing them and having them experiment and develop their own understanding by doing, probably by seeing, by watching, by discussing, but also by doing. To actively augment digital information-based work. It could be for information gathering, analysis, creation of content, production, presentation, and distribution, because everyone gets to work with it. I think that was in the chat as well. For understanding the use of algorithms by companies and governments, that reflects some of the responses in the chat. For being able to co-build your own models. It's interesting. That's why you should know more about AI, because probably you or your coworker will use it. It's the future of work. There will be a lot of job opportunities within the field of AI from many different industries. It's the language of your future coworkers. Obviously, if you don't want to be in AI, your coworkers will be. So if you want to talk to them, work with them, you have to understand them. They have to understand you, but you also have to understand them in return. And 7th, which I just learned, that learning new things is crucial to professional happiness. So obviously, you don't have to learn AI as the only new thing, but learning new things brings you professional happiness, and AI could be one of the new things you might be learning this year. So my name is Vreekamp. I'm a founder of Future Journalism Today Academy. I wrote The Art of AI. I've got the book right here in my hands, which came out 2 weeks ago. It's an introduction in machine learning for media professionals. I'm a mentor at the Dutch Journalism Fund, Stimuleringsfonds voor de Journalistiek in the Netherlands. And I'm a member of the expert committee on AI and media at the Council of Europe. And before that, previously, I worked at Google for the News Lab as a teaching fellow. I was a research fellow and lecturer at the University of Applied Sciences Utrecht with the School of Journalism and Communication and Media Design. I used to direct a nightly radio show on Dutch Public Radio 1. And I was trained as a UX designer and did this for public broadcaster, KRO-NCRV. Now, I think we have just a few minutes left. It says these 30, but we will get to the core of this presentation right now. So I'll address these questions. How do you incorporate AI into your creative process? And what methods are there to introduce AI to your team or organization? Now, at the end of the session, you are updated on a few concepts. And I hope you know what methods and tools you can use. And I will give you a wrap up, and it will be in the handout as well. And you have the AI powered tools and toolkits at your disposal. But first, because I don't know how much knowledge you all have, let's do a little quiz. Just 3 questions. Which elements are essential for a definition of AI? Put it in the chat, A, B, C, or D? So we're not finding the universal definition because there isn't one, but which elements are essential? Just to gauge what the level of knowledge in this group is. So put it in A, B, C, or D. All four. I see some B's, some A's. Yeah, mostly B, and B is the right answer. And because the other things all have one element that it's not per se necessary. Neural networks or robots don't have to fit into a definition of AI. They could involve AI, but it's not necessarily a element, basic element. Second one, which three machine learning approaches are there? A, B, C, or D? Can I have your answers, please? For question 2, I see A, D, more A's. So a lot of A's, so the wisdom of the crowd again is right: supervised, unsupervised, and reinforcement learning. And then last one, which approach uses labeled examples? Is it reinforcement, superficial, labeled, or supervised learning? Again, may I have your answers, A, B, C, or D? I see D. Yeah, a lot of D's. I think you're probably all right. Again, yes, it's supervised learning. So let me get into the humans, the card sets, and the toolkits. First, this is Dasha Simmons. She's a managing consultant at IBM, AI and AI ethics, and she works with clients. She uses design thinking methods. And she does that to explain and discuss important concepts and consequences of AI. And she puts herself in the role of various stakeholders that are involved in these projects. So she asks questions like, what does it actually mean for a data scientist when she goes to build a non-discriminatory AI model? So if it's Tuesday afternoon, what do you do on a practical level? So she says design can help to make that challenge tangible, so to make it actually foreseeable. And with a prototype, for example, you can really test ideas and concepts for implementing AI. Now, if you're not familiar with design thinking, this is a double diamond model that I've used in the book as well to grasp the creative process. Discover, so you go in a divergent mode, define, you go in a convergent mode. Again, then you develop ideas. The first is understanding and the second is generation. So develop ideas and deliver on ideas. And one of the things, it's interesting, Dasha works at IBM, and it was founded in 1911, so it's over 111 years old, on June 16 as International Business Machines Corporation in New York. And they outline the belief in their AI essential framework. And they say, when we find ourselves in uncharted territory, and for most AI is that territory, the best place to start is by reminding ourselves of the real purpose of any innovation, to improve the quality of human life. And according to IBM, AI has 4 main qualities: understanding, reasoning, learning, and interacting. So this is their model from their AI Essentials framework. And they start with business, world, machine, human, business, because they're international business machines. Start with an intent, then look at data and policy, and then the 4 qualities of AI: understanding, reasoning, knowledge, expression, and then human obviously respond. They have a user reaction, they learn, and then there's an outcome, which could be used by businesses. And this framework helps organizations to develop future scenarios and address hard questions before even building AI-powered applications. And this is what IBM uses as their essential framework. And you can find all these resources online. It helps you from a broad view to think about and conceptualize about the impact of AI. Now, I'll show you a few examples which go from very broad top down onto the very micro level of designing actual screens or interfaces for AI. Now, this is the machine learning canvas, and there are a lot of canvases out there: business model canvas, value proposition canvas. Well, this is a handy way to look at the different elements of your idea and to have a structured way of thinking and discussing, which is very visual. So the way to use it, you start in the middle with the user and the value proposition. And from there on, you go to the other parts, like to the right, data collection, the data sources, the features. So if you were to build a hiring algorithm, then maybe years of experience and the degree are relevant, but nationality and zip code maybe aren't. So you can think about that. So where do you get the data from? And then you move on to the canvas, and it helps you to again discuss and devise in a structured way what you would like to do with machine learning. Now, if you want to know if it's actually able to do that, then you might look at the third example, which is a card set by the Stanford D School. I love algorithms. This helps others and yourself to develop a basic understanding of AI. It's a card set from the Stanford University D School, and it allows anyone technically skilled or not to create prototypes with machine learning's additions, and they call it low resolution. And so you spend less time perfecting your idea and the look and feel, and more discussing it meaningful to see if your solution really is worth to pursue and to proceed. So they've got all these different these commonly used algorithms like classification, clustering, reinforcement learning, regression, association, and they explain it in 3 ways. So this is classification, which is more of a definition, then an example, the bagel or donut, and then a use case or different use cases where you could use the classification approach as a machine learning concept for your solution. So this card set, which you can download online or even print you can download as a PDF, helps you when you're discussing or concepting the use of machine learning for maybe a new product or service which you're coming up with. Now, there's another type of card set which was co-developed by Nadia Piet, who is now a head of creative technology at Dept, which is a creative agency. She works in a research through design way. And well, it means that the designer fleshes out ideas and literally shapes those ideas into form, visualizing, sketching, building, prototyping. Then she has artifacts to communicate. Then she invites others to reflect on these ideas. And for that, she uses creative concepting workshops and these card sets. And I've got some of them right here. And I don't know if you can read it, but this one says, what if you can understand the physical context of where your user is and what they are doing. And they've got all these different themes on what ifs for different purposes, different uses. And this card set, which is a very neat box, which you can order online, is an inspirational and practical guide for designers and managers and innovators to learn about possibilities or to prompt to come up with new ideas, new ways of using AI. So one of the cards, for example, say, what if the user could interact with the system using your voice? And they have categories like personalization, aware of context, perceiving physical space. So it's interesting if you need more ideas when to generate ideas or discussions, using this card set, hand them out in your team, and then see what happens when you discuss ideas. Now, I'm almost wrapping up because considering the time, it's 1:03. Which 2 popular types of machine learning applications do you see at work in the next example? And you might know this one. So there are 2 types of, or 2 distinct types of computer vision. I'll help you a bit. So this is where Dries de Poorter used computer vision to automatically tag Belgian politicians when they use their phone on the daily live streams during debates in Parliament. What 2 machine learning applications did he use to make this sort of interactive AI-based installation? It's an open question. So 2 specific subtasks of computer vision, just to get an idea on your knowledge of AI. Put it in the chat if you know the answer. So again, face recognition, that's the first one. Yeah, Peter, you were very fast, Patricia as well. And the other one, object detection. Yes, you've got it. So it's face recognition and object detection, because he had to recognize all the politicians and then had to make sure that if he could detect if they're using their phone, if there's a phone in the image from a certain angle, and then if the matched politician with the certainty of 80% phone usage, then that politician would get a tweet or an Instagram post with their name and say, hey, pay attention. It's in the national interest, this debate. It's more of an activist thing. Now, the Vlaams Kenniscentrum Data Maatschappij, they came up with the Intelligence Augmentation Design Toolkit to offer this to, again, to people that are thinking about using AI systems, but also about maybe unexpected consequences. What could go wrong? And this is a card that helps you. It's called the Pretty Bird Unexpected Bug. System learns the wrong thing from the data, and predictions aren't useful for the original goal. For example, image recognizer detects background conditions instead of foreground objects. So these cards could help when you're already conceptualizing and maybe prototyping your solutions. And then these cards could help to be critical and to ask meaningful questions about your solution and your design. Now, and as you can see, we're at the fifth card. We're going to the last two toolkits from Microsoft and Google. Microsoft has been offering this human experience toolkit online. So if you're in need of guidelines, they've put a nice collection online with examples and practical, useful material when you're designing AI-powered products. And on the right, they see Microsoft is showing an example of Google Photos about how it's done when you're showing users what kind of things the system can detect, like monuments, birds, beaches, rainbows. And it gives you all kinds of advice on how to use and guide the user when your product or system is AI powered, how to design cues, how to design even buttons or messaging. Last one is patterns, AI patterns by Google. It's from the PAIR collection, as they call People and AI Research, and they provide all kinds of patterns, action-oriented guidance on AI product design and examples. Now they have these two examples, and it could be a quiz. So what would you consider a bad example, and what would you consider a rather useful example of AI when it comes to workouts and personalization with an app? So who says the right one would be a really neat feature of AI for when you do workouts? Then put in right in the chat, and if you say left, then put in left. So let me guess. Right, I've got one. Adrian would say, well, based on music you like, workouts paired with popular music genres, speed walking, beginner weights, advanced tennis with jazz, core and more with new gaze. Left, Patricia says left, and it's based on your workout history, scenic routes, urban paths, interval training, sprints and relays. Now, the answer that Google gives you within the best practices is that go for left, because you only use the AI system when the prediction is valuable to the user, and that wouldn't be there if there were no AI. But on the right, it seems like that you're using AI just because you can, and you can use heuristics or other procedures that give you a better experience. So looking up musical tastes to recommend exercises will maybe be a bad experience. Maybe for some it might be funny, but not the best way if you want to exercise, work out, or get in shape. So Google tells you to go for the left example, which would make more sense. Now, come to the end of this talk. I hope you, it might have gone quite fast. I hope I've given you new solution spaces, as Dasha Simons from IBM calls it. Like with Mark Rutte, using humans and machines in collaboration, in the companionship. But also, if you know that by just typing a sentence, a text command, and it can generate images, what would it do for your creative possibilities, opportunities? And also, solution spaces. Sometimes you need algorithms, but sometimes you can use machine learning models to arrange information, like books on a shelf. So think about what your how AI might broaden your solution spaces. And well, we've come to the end. So I would like to ask you, are you updated on a few concepts of AI and ML? Secondly, do you know what methods and tools you can use for concepting with AI? And third and lastly, do you have AI-powered tools and toolkits at your disposal, or maybe now have heard for the first time, to go for a fair and balanced development of AI-powered products and services? I hope you do. This is the list that helps you in a practical way. And again, I think Isabelle and Stefan will share the presentation in PDF, but also these links for you to look up when you're about to embark on AI product or service development or discussing possibilities. Thank you very much.